Hey, welcome back to this series. Today we are in fifth part of this series. In the first fourth parts, we had explained about our folder structure, GD&T, simulation, and strip layout. Today we are going to check the die design. How do we do it? For this particular part, we had to do 11th revision before it got approved from the customer. I'll show you the very first what we did and then probably one more and then the last one. Okay, so here is the die design. As you can see, we preferred our dies to be designed in Unigraphics. Right, tomorrow we might we might change it, but as of now it's Unigraphics. Personally, if you ask me, Unigraphics is the best when you do the die design. Much easier, much better, and the best feature which I like here, like you can make it completely unparametric, right? So let me show you the die design. Now, during the design phase, we design the die completely in layers, right? So as you can see, we have, let me make it bigger so you people can see it more better. Okay, so we have all these things here, right? So we have final data, body sketch. We don't have to go into this. Uh, Let me make one as work layer, right, and let me hide everything else. Okay, as you can see, we don't have anything, right? Usually under 100, 101, 110, 120. If you see, oh, let me 101. Okay, so 120 we have these three parts which are no need. 110, what we have in 110, man? Okay, so we have the part here. This was the in the beginning. This was it, right? You remember the very third part I had explained that we had to change this. So 101. So this is our strip layout. Let me show the top view. See, as you can see here, this is the very first strip layout, not the final one, right? Oh no, this is the final one. This is the final one here. So as you can see, we have all these informations here. So strip layout is there. And then let me show you the lower. Okay, okay, so from 30 shift. Okay, so you see we got the lower die, all right, and we also have the lower base bolster. You see the die has to be as per this information. We also maintain the pass height. As you can see, the pass height is 4431.8, right? That is 17 inches. That's what we got from the customer, right? And the set height is 32 inches. All these we got from the customer. Correct? Now, one moment. Yeah. Sorry for the interruption. Yeah. So, okay, let me hide this information and let me also hide 101. Right. So, what we have here? Slowly. Let me. So, 100. All right. Let me make it transparent. It will be better if I make it transparent. So 30 to Oh, okay, and let me make it transparent. This will be easier for you to understand. Okay, okay. Shall I make the background white? Background, light background. Okay. Now I start from here and here. Okay. As you can see, so this is my strip layout. What we have here, we have uh, one pilot pierce and trim, and one more pilot pierce pitch notch. So what we have done, see, the very first requirement. uh, Let me first explain what are all the elements in this die. As you can see, this is the bottom plate on which and everything is assembled, right? These are the parallels. Parallels are because a press at height will be like anything, and we cannot make this that bigger. So we keep it like 4 inches, 3 inches, 5 inches, 6 inches thick. This bottom plate as per our standard. In this case, we have probably taken 4 inches. I believe it's 4 inches. Let me check that. Yeah, yes, it's 4 inches. So that's what we have taken, and rest that gap we used parallels. It saved our material, machining, everything. So that's the standard. So we have this parallel, right? Wherever we have clamping slot, that's clamping parallel, and otherwise normal parallel. All they are lower parallels, right? Now let's start from here. All these corners we have a stop block. What happened when the die is closed? Then it will the upper die will rest upon this. As soon as upper die will touch this, we know that stroke is done, completed. How do we check that? You see this groove here. So this groove thickness is 1.27. That's 0.5, right? 0.5 we say, like 50 thou. We say 50 thou. It's inch standard in USA our customer end. Even though we in metric also, if they have metric also, we maintain it 50 thou. So this is 1.27 millimeter deep, right? What happened? We have very soft aluminum wire, and we keep it here. When the upper die come, it hits. So upper die, whatever elements are there, so that will hit against this, right? And then it will like make it thinner, 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 thinner. As soon as, and we keep on checking using a micrometer or a 1 year caliper, and we see as soon as 1.27 we know, okay, it's done. Okay, so it's hitting now. We leave, actually we make it 1 point, even though the groove is 1.27 mm deep, we sometimes just keep it at like 1.3 or even little bit more, so that it does not hit just kiss. When it hit, it means you are going to add some more pressure, more tonnage. Just kiss, then just kiss it, no more pressure, right? Okay. And these four, it's easy for you to understand. These four are nothing but guide pin, guide bushes, right? Guide bushes for upper die. And then like it has multiple forms and all. So to control the control the forces, we have these two lower guide blocks. So what happened? We have guide post in upper which comes, and that is the way we try to balance and provide some thrust, balance out the thrust because of the shape of the part, right? Now these are stock guides. Here you are stock guide, here is stock guide. You see these two are movable and these one are fixed. This is the front side, right? Because our stock, that coil width could be less, could be more. It has a tolerance, right? So within that range it might be less or more. So you need to adjust it. You may need every time during setting, you might need to move it or you might need to move it back.